Most people say, I know SQL joins. And honestly, I understand why. At first, joins look simple. Inner join, left join, match the two tables and get the result. But in interviews, joins usually don't become difficult because of syntax. They become difficult because of missing values, null values, duplicate rows, and wrong row counts. So in this video, I will explain joins in a practical way using 3 interview style questions that every data engineer should understand. And don't worry if you are a beginner. I will keep this simple and build it step by step. Hello everyone, welcome to Big Data Fact. I am Pranit and I have 4.5 years of experience working as a data engineer. This is the second episode in our SQL series. If you haven't watched episode 1 on window functions, I would recommend checking it out after this video. It will give you a strong foundation. And if this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Before we solve the questions, let's quickly understand the main types of joins. Inner join returns only matching records from both the tables. Left join returns all records from the left table and matching records from the right table. If there is no match, the right side columns becomes null. Right join is the opposite of left join. It keeps all records from the right table and matching records from the left table. But in real work, many people avoid right join and rewrite it as a left join by changing the table order because left join is usually easier to read. Full auto join keeps matched and unmatched records from both the tables, so if someone exists only in table A or in table B, it still appears in the output. Some SQL engines support it directly and some handle it differently. Cross join creates every possible combination between the two tables. So if one table has 3 rows and other table has 4 rows, the result will have 12 rows. This is useful in some cases, but dangerous if you use it accidentally. Self-join means joining a table with itself. For example, employees and their managers can come from the same employee table. And finally, there are patterns like anti-join and semi-join. Anti-join means find records in one table that do not exist in another table. Semi-join means find records in one table that have at least one match in another table without bringing all the matching rows. Now in this video, we will focus more on the joins that commonly appear in interviews and real data engineering issues such as left join, inner join, null handling, duplicates, and row count problems. Let's start with the question 1. Find users who never placed an order. Suppose we have two tables. One table is users, it has user ID and username. Another table is orders, it has order ID, user ID, and order date. Now the question is, find all users who have never placed an order. This is very common SQL interview question and also a very real data engineering scenario. For example, maybe the business wants to know which registered users never converted. So here is the query. Now let's understand this slowly. We start from the users table because we want to check every user. Then we use a left join with the orders table. This means keep all users whether they have an order or not. If a user has placed an order, the order columns will have the values. But if a user has never placed an order, the order columns will be null. So we filter order ID is null. That means give me only those users for whom no matching order was found. This pattern is called anti-join pattern. In simple words, use left join plus is null when you want records from one table that do not exist in another table. So someone asks this in an interview, don't overthink it. The logic is start with the main table, left join the second table, and filter where the right side is missing. Now let's move to the second question. This one looks small, but it catches a lot of people. Question 2. How many rows will this join return? So here, table A has values 1, 1, 2, null. Table B has values 1, 1, null, 3. Now we run this inner join query on both the tables. So the question is, how many rows will this query return? Take a second and think. The answer is 4 rows. Now let's understand why. In table A, the value 1 appears 2 times. In table B, the value 1 also appears 2 times. So everyone from table A matches everyone from table B. That means 2 rows from A match with 2 rows from B equal to 4 rows. So we get 4 matching rows for the value 1. Now what about 2? There is no number 2 in table B, so no match. What about 3? There is no 3 in table A, so no match. And what about null? This is very important. In normal SQL, equality joins. Null equal to null does not become true. So the null in table A does not match the null in table B. That's why the answer is only 4 rows. Here is the key lesson. Duplicates multiply in joins. And null values do not match using a normal equality condition like a.id is equal to b.id. This is one of those small concepts that can save you from many wrong data engineering answers. Now let's go to the third question. This one is extremely important for data engineers. Question 3. Why is my join creating duplicate rows and wrong metrics? Let's say we have two tables. First table, orders. It contains order ID, customer ID, and order amount. Second table, order items. It contains order ID and product ID. Now remember this carefully. The orders table is at order level. That means one row represents one order. But the order items table is at item level. That means one order can have multiple products. Now suppose someone writes this query. At first, this query may look correct, but it can give the wrong result. Why? Because if one order has 3 items, then after joining with order items, that one order appears 3 times. So the same order amount also appears 3 times. And when we do sum of order amount, we may count the same order amount multiple times. This is not a syntax problem, this is a grain problem. Grain means what does one row represent in the table. In the orders table, one row means one order. In the order items table, one row means one item inside an order. When you join tables with different grains, your row count can change. And if you aggregate after that without thinking, your business metrics can become wrong. So if your goal is customer level order amount, a safer query is this. No need to join with order items unless item level information is actually required. And if item level data is required, then first aggregate the data with the correct grain and only then join. So the lesson is, before writing a join, always ask what is the grain of the first table, what is the grain of the second table, and will this join increase my row count? This is how data engineers should think in real projects. So let's quickly recap. If you remember only 3 things from this video, remember this. First, to find missing records, use the left join and filter where the right table is null. Second, duplicates multiply in joins. If a value appears 2 times in one table and 3 times in another table, the join can create 6 rows. Third, wrong table grains create wrong metrics. If a table is at order level and another table is at order item level, joining them can create duplicate rows and inflate your numbers. And this is why joins are so important in data engineering. Because in real pipelines, a wrong join does not give just a wrong SQL answer. It can create a wrong dashboard, a wrong report, and a wrong business decision. So next time when you write a join, don't just ask, is the syntax correct? Ask, is the row count still correct? That one question will make you much better at SQL. In the next SQL video, I can cover CTEs, subqueries, or case statements with real interview questions. If this helped, drop a like, subscribe to Big Data Factory, and comment joins so I know to continue this SQL series. This is all for today. We'll meet you in the next video. Till then, keep learning and keep building. Bye bye.